part one of a two-part video of the Quanta magnetic motor generator. In part one, I'll be describing the parts and the operation of the machine, and in part two, we'll show it in operation and some of the other things that it can do. First, we'll talk about the pulse motor. We have a permanent magnetic stator that's made up of the Howard Johnson 6-segment operation, the 6-segment configuration, and where each one gets a little closer together and then starts over again and a little closer each 6 times. And it's also got a little bit of a Wankel twist to it, so it starts a little further away in the beginning here, it gets a little closer at the end, and then it's pulsed with the electromagnet. Now it has one magnet here on the rotor. It's powerful, it's an N52, and when it gets up to the electromagnet, you'll see the LED come on, and it fires just for that short duration, right in there, and it's off. And then it goes on its own path and continues to want to make the completion of the circle, but ends up only getting about a 340 to 350 degree radius on its own power. There's no sticking points, so you can start it at any point. Say if you started it with a magnet straight up in the air here and let go, it's still going to continue. If you start it over here, you can see it. It's going to continue, even at the very bottom, and it continues. So, with a very simple push, it wants to go round and round and round, but it stops at the electromagnet. So the electromagnet is pulsed just for that brief fraction of a second and continues the rotation. The rotor stator configuration is not unlike many that you've seen, but that's the point where this machine takes off and differs from the rest that you have seen. The controlling of the electromagnet on this particular machine is done with a solid-state relay. This relay this is the switch side, this is the contact side. It's very powerful, unlikely that you'd burn this monster up because it'll fire the switch at as low as about 3.5 volts and up to 32 volts of DC. It's a DC solid-state relay. On the contact side, it will close the contacts anywhere from 0 up to 480 volts DC at 20 amps. So it's a monster of a contact system. All field effect transistors, so it's very powerful, and again, with a little bit of power that we operate with this, you're not going to hurt it. Now the re-gauging part of where the magnet goes from the end of the stator to the beginning of the stator here, and triggers. You've seen the LED light up right there at that point, and that's triggered by this little cam here. You can see the little knob on the top here, and all it does is it just pushes in a couple of copper contacts together. It's all nylon, and there's a little set screw at the top, if you can see that. I don't know if this video is very good, but a little set screw on the top, and so you can advance or delay the pulsing of the electromagnet to any point that you want. And the idea is at this point where it fires, it's just before top dead center and then just after top dead center, and so you get the full benefit of the full power of the electromagnet. Now the purpose behind that is to keep the electronics simple as far as using this nylon cam here to fire the solid-state relay. So we've got the solid-state relay, and we just got a couple of bridge rectifiers that rectify the power from the 3-phase alternator. Let me see if I can spin this so you can see it in the light a little bit better. There we go. And we've got 12 very small coils here, inside here, the green coils, and we've got dual rotors. If I turn it a little bit, you can see it, that turn past on either side of the coils. There are 16 positions for these, and They're only 1/8 inch thick, 1/2 inch wide, 1 inch long. But I've got a row of 3 of them back here and a row of 2 of them on this front little rotor, all in the same shaft. Has one moving part, that's it. Is just that rotor. It weighs about 5 pounds, so it also acts as a flywheel when it gets going very fast. So that works to your benefit. But all these little magnets in here are N52, so very, very powerful. So you can turn this thing with one finger. It's so easy to spin because it's a 3-phase alternator. And even at that, spinning it about this fast here, you're generating about 50 watts of power. Pretty amazing for such a tiny little pancake alternator. The power is rectified then. Let me turn this around a little bit here. The AC power is rectified here and fed right into these capacitors, DC power. And each one of these is 2.5 volts times 5 is 12.5 volts. I usually charge it up to 3 volts each, and it's simply by turning the crank, 2 fingers, your thumb and your index finger, turn this for a few minutes and you'll charge up these capacitors, and then the machine will in turn, gaining all this net gain here, you think, well, whatever you gain you're going to lose right here at the end because it stops. Well, that is partly true. And I say partly because the faster this turns, the faster this fires. The back EMF comes off of this coil and goes back into the positive of the system, feeds back into the capacitors, and kind of keeps the system charged at the same time. So the faster that goes, the higher your spikes are on your back EMF, and it actually will extend the duration, the runtime of the rotor from just these capacitors. There's no batteries, there's no outside power. You can bring outside power in by simply disconnecting the positive up here on this capacitor here, and you can bring in power. There's 2 right down here. There's a positive and a negative, and you can bring in auxiliary power if you want to, but you don't have to because the system is pretty much self-contained otherwise. You just turn this crank for a few minutes, charge up these capacitors, and this motor will run between 1 to 2 hours. That's pretty amazing. And not only does it run up to 2 hours, but it'll run, if you turn this at this speed here, about 200 RPM. I'm doing it with one finger, it's so easy. It will actually run at about 400 RPM for that duration of time. So it's pretty amazing because it's only pulsing this thing, so it's super, super efficient. And using that back EMF and adding that to the system is just quite amazing. The switches down here are for the configuration of the 3-phase alternator. And it's an axial flux alternator. It's the same type that they use in a lot of the home-built windmill systems. Very, very efficient, for 3-phase. Just a beautiful little piece. And I've hand-built all this. This machine's about, let's see, I built it in 2007, and I've added to it and changed it. And I've put things like this little on-demand high-frequency generator at the top, which is a lot of fun. You just turn the switches on here and turn the crank. Watch. Or you can get a higher arc out of it. I'll turn the lights off in the next video so that you can actually see those sparks. These lights are so bright that it doesn't quite do it justice. Also, the little high-frequency generator is mounted with neodymium magnets. You can see them on the base there. So it just snaps in place. Kind of cute. Keeps it all magnetic. These are the stator magnets you can see inside here, over in this area here. They're bar magnets, 1 inch wide by 3 inches long, 1/4 of an inch thick. I think they're N42, so there's quite a bit of magnetic power if you look at all the way around the stator. There's quite a few magnets in there, and in some places they're doubled up, like right here at the beginning and ending in the beginning here. and maybe a couple of other places. The stator is actually a tuned magnetic field, and you wonder what that means. On the back side of these inside the case, it's the only other thing that's inside the case, is additional magnets on the back that strengthens the field so that it has no sticking points, increases the power, and it allows it to, gain so much more momentum on its own while it's spinning. And this 5-pound flywheel that encompasses the big flywheel here, the big rotor with the single N52 disc magnet on it there, and this here again, it's 5 pounds. It's quite heavy, but when it gets moving pretty fast, even at 400 RPM, which isn't really great, I had positions. I don't know if you can. Yeah, you can see. I think in the video here, you can see where I had another one cut out here. I actually had 3, and then there was one right in there. I don't know if you can see that, the little square. Yeah, you can see where the square is there. So I had 3 of them in there, and it was great. I mean, it operated at 3 times the speed. It was 1200 to 1300 RPM, and it really moved out. But the duration was slower because it had to pulse the electromagnet 3 times instead of 1 time. So I thought, okay, well, we'll just knock it down to 1 and set the distance accordingly from the electromagnet to the rotor magnet, and just maximize it that way. And it works out really, really good. So again, back to these switches here. Sorry about that. They control the wiring setup of the 3-phase alternator. When they're both in the down position right here, it's the delta configuration, which gives you low voltage and higher amperage. When they're in the up position, it's the star configuration, which gives you high voltage and low amperage. Well, if you consider the fact that these are only going to max out at 3 volts apiece, so you're going to be running from 12.5 to 15 volts on the capacitor, you want low voltage and high amperage so that these can charge up by just turning the crank just, for a short duration. And so the best position to have them in is the delta, but it's fun to experiment because you can kind of mix and match. There's 2 phases on the red one and 1 phase on the black switch here. That's why they're in 2 switches. I just had 2 positions on each switch. So for 3 phases I needed 2 switches. But it's fun. So this has been a real educational machine to build and to operate. These switches up here turn on the same thing about the coil phases and so forth, that they turn on the electromagnet and turn off most of the power from the 3-phase alternator. We do get a little trickle power off that, and that also feeds the system here, but mostly it's the back EMF is feeding back in, which extends that duration of runtime up to the 2-hour period. Sometimes it'll run for about an hour, and then it'll slow down and stop and reverse and run in the opposite direction for another hour. So it's kind of unusual. It's got a lot of unusual characteristics of a motor of this type, motor generator of this type.